Okay, this is FLP page 27. It says properties of quadrilaterals. Go through here and label a bunch of this stuff, and then we'll go down and answer these questions at the bottom. All right, first of all, we'll start with naming this one a quadrilateral. If you notice, it's got four sides. 1, 2, 3, 4. And this is the weird quadrilateral we talked about earlier, where it doesn't really fit any other explanation of these figures except for just calling it a quad. Okay, it doesn't fit with the parallelograms, doesn't fit with trapezoids, so it's just a quad, period. Let's go to the left first. You can see that this is a parallelogram. Okay. Below that, we've got a rectangle. And over here, we got a rhombus. And we've got a square. Okay, and to the right side of the quad, over here, we got the trapezoid. Okay, and this one right here is just a regular old trapezoid. Come down, if you look, we've got, and I would make a mark there and there, showing that those two lines are congruent, and this one's called an isosceles trapezoid. Reason being is because it's got two congruent sides. And then over here, it's pretty much just a trapezoid, but I call this one the 90-degree trap. And the reason being is because you'll notice that that's 90 degrees and that one's 90 degrees. Okay? Let's go answer some of these questions. It says, for each following statement, select true or false. All quadrilaterals have four sides. True. That's why they're called quads. Number 2, the opposite angles of rectangles are congruent. Yes, they are. They're all 90 degrees. All trapezoids are parallelogram. Actually, no trapezoids are parallelograms. Parallelograms have two pair of parallel sides, and trapezoids have exactly one pair. All rectangles have exactly one set of parallel sides. No, they have two, so that's false. Let's go to number 5. All parallelograms have diagonals that bisect each other. That is true. Number 6, all squares are rhombuses, excuse me. By definition, yeah, that is true, okay? Because in order to be a rhombus, all you have to have is two pair of parallel sides and four congruent sides. That's it, and the square matches that. Difference between the square, the reason the rhombus is not a square is because the square has to have four 90-degree angles. So that's the difference there. We'll call that true. All rhombus have four congruent sides. Yes, they do. Not all squares are rectangles. That is false. All squares fit the definition of a rectangle. Definition of a rectangle is two pair of parallel sides, four 90-degree angles. That's square, okay? The reason a rectangle is not always a square is because squares have four congruent sides and not all rectangles do. So that's the difference between those two. All right, all rectangles have perpendicular diagonals. Now this word right here means that it would form a 90-degree angle. So like perpendicular means that these lines right where they intersect form 90-degree angles all the way around like that. Okay? In this case, not all rectangles have perpendicular diagonals. Some of those angles will change and they won't be 90 degrees. The total degrees in a quadrilateral is always 180 degrees. That is false. It is always going to be 360 degrees. Okay, cool. That's 27. Let's jump to 28. This one might take us a little bit, but we can roll through this. I'm going to show you how to do these. If you notice, I think I did number 1 for you. So let me explain what happens here. These are all parallelograms. So that means that opposite angles are equal or congruent. Opposite sides are congruent. So it makes it easy And then we have to think about any quadrilateral. If you add all those angles up, it's got to be 360. So I don't know if I wrote it on the page somewhere. Yes, the sum of the four angles of a quad are 360. So what I've done here is I find the angle that I have. I know the opposite angle is the same. I add those two. I subtract them from 360. Whatever I have left is these two angles, but I must divide by 2 because there are 2 of them. Okay? I did that for 1 and 2. Let's just jump right into number 3. It won't be bad, I promise, as we go. First thing we're going to look for is what angle do we know is 41 degrees right here. It doesn't have a letter. It's opposite of x. So we know x is 41 degrees. Okay? We can take those two angles, 41, and add it to each other. We know that equals 82 with a calculator. I know all quads must equal 360, so I'm going to take my 360, subtract what I have of 82. It's going to give me 278. I know that this 278 combined takes care of my other two angles, so I take the 278, divide it by 2 angles, and I get 139 for the 2 missing angles that I have. So y is 139, and z is also 139. If you notice, y and z are opposite angles, so they're congruent too. And if you see this little curve, that's one curve, they're congruent. If you got 2, that means they're congruent too. Okay? Let's go to 4. I'll try to get through these really quick so I'm not holding you up for a long period of time. Let's jump into 4. It says, gives us an angle of 60 degrees. The opposite of that is x, so we know x is 60 degrees. Again, we got 2 angles. 60 plus 60 is going to equal 120. 360 is my quadrilaterals. Minus, I already have 120, which is going to leave me with 240 degrees. I need to split that among 2 angles. 240 divided by 2 equals 120. So I know that y and z are 120 degrees, okay? So if you added the 60 that's there, that's 60, 120, 120, you're going to get 360. Cool, let's look at 5. We're given 100 here. Opposite of that is x, so we know x is equal to that, so it's 100. So we know, let's add 100 plus 100 equals 200. I love it when I have these nice smooth numbers. The total's 360. We subtract the 200, that's going to give us 160. Ran out of room up there, I'll go right here. 160. Divide that with 2 angles, which is going to give me 80. So I know I've got 80 degrees here and 80 degrees there. Okay? Look at 6. Telling me that that's 150. Opposite of that is x, so I know x is equal to it, so it's 150. Again, if I add 150 and 150, I get 300. Okay? Total of a quad is 360. I subtract the 300 that I already know. Leaves me with 60. If I take that 60 and divide it by the 2 angles that I need, I know each one is 30 degrees. Okay. Okay, cool. Got 3 more of these, I believe. All right, number 7. There goes the clock. All right, so it says, what is it? The given angle they've given us is 85. It's opposite of x, so we know x is 85 also. So let's go up here and add my 85s. 85 and 85 is going to be 170. My total for a quad is 360 minus 170 that we found leaves us with 190. Okay, if I take my 190 and I divide it by 2, it equals 95 degrees for y and z. Okay, Two more. Hang in there. 40 degrees here, opposite of 40 is x, so x is equal to it, so I know it's 40 also. Okay. We have a 40 and a 40 is 80. I got quads are 360, so I subtract the existing 80. Gives me, what is 360 minus 80? 280. I need to divide that amongst two angles, so I'm going to take my 280 and divide it by 2, which gives me 140 degrees for my y and my z. Okay, last one. We see a given of 135. The opposite angle is x, so we know x is equal to or congruent. Opposite angles are congruent in all parallelograms. Okay, so let's add those two. I have 135 plus 135 gives me 270 existing degrees. All quads are equivalent to 360 for four angles. So I'll subtract the 270 I already have, which gives me 90. I'll take my 90, split it up into two angles that I have left, divide it by 2. Is going to give me 45 degrees for y and z. Okay? I think you should be good to go there. Remember, there's already an angle here, and if you take that, add it to that, add it to that, add it to that, they're always going to equal 360 for all quadrilaterals. Okie doke. Thanks for watching this one. Catch me on the next one, please.